Welcome to BTEC Revision. In today's lesson, we're looking at angular and tangential velocity. By the end, we should be able to calculate the angular velocity of objects and calculate the tangential velocity of objects. For example, let's take a circle with radius r. And if we have an arc length, which is a length curving of the circle, which also has a length equal to the radius, then this angle created here is equal to a radian. And we are able to fit 2 pi radians within this circle. And we also remember that we can fit 360 degrees in a circle. So we can say 2 pi radians equals 360 degrees. Now we can look at angular displacement. Angular displacement is the angle through which a point has been rotated. And the unit for this is radian, or RAD for short. Unlike normal displacement that we used to, instead of measuring distance, we are measuring the angle. We are measuring how the angle is changing for any object in circular motion. For example, if we have a full cycle, that would be a 360 degree rotation, which is equal to 2 pi. So the angular displacement is 2 pi. Now we can look at angular velocity, which is the rate of change of angular displacement, and it's measured in radians. Here is the equation that we can use. Angular velocity equals change in angular displacement divided by change in time. And the short form of this is omega equals delta theta divided by delta t. The units we can use are seconds for time. Angular displacement, if you remember from the previous slide, is measured in radians, or rad for short, and angular velocity would be radians per second. If you can see here, this is similar to our previous lesson on velocity, which is displacement divided by time. This is measuring how much displacement is changing over time, whereas in today's lesson, we are measuring how angle changes over time. For example, if we have an object that rotates through an angle of pi over 2 radians, in 2 seconds, calculate its average angular velocity. We will start by writing down the equation. Omega equals delta theta divided by delta time. Now we can plug in our values. We know theta, change in, is pi over 2, and we'll divide that with the time, which is 2. That gives us a value of pi over 4. And the units are radians per second. Now we can look at tangential velocity, which is the rate of change of angular displacement, and it's measured in radians per second. So we can use this equation, tangential velocity equals angular velocity times radius. And the short form of this is V equals omega r, where V stands for tangential velocity, omega stands for angular velocity, and r stands for radius. The units for this are, well, V is measured in meters per second, omega is measured in radians per second, and r is measured in meters. Let's look at this example. A point on a rotating object that is moving with a tangential velocity of 2 meters per second and is 0.5 meters from the center of rotation. Calculate the angular velocity. We can start by writing down the equation. V equals omega r. Now, the question is asking for angular velocity, so the symbol for that is omega. That's omega equals V over r if you rearrange the equation. And tangential velocity is 2, and the radius is 0.5, because it's saying 0.5 meters from the center. And that will give us a value of 4 radians per second. Now let's look at this exam question. Pause the video here and attempt this question. The question is saying, to calculate the radius of a wheel given the linear velocity is 20 meters per second and angular displacement is 2 pi in a time of 2 seconds. We can start by writing down the equations. V equals omega r and omega equals delta phi over delta time. Now, the question is asking for the radius. So we can rearrange this first equation for radius. R equals V over omega. And we need to work out omega. You know what V is? That's 20 meters per second. So we can use this equation to work out omega. So let's work out omega first. So that's delta theta. It says the angular displacement is 2 pi. So that is 2 pi divided by a time of 2 seconds, which gives us a value of pi radians per second. Now we have omega, so we can plug in our values. R equals V, which is 20, and omega, which is pi. So 20 divided by pi gives us a value of 6.37 meters. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com, where there's lots more resources available. See you next lesson.